Okay, so let's see. Yesterday we worked on parallel lines with transversals. So things that look like this. So remember L and M would be parallel. And what would happen to all of these angles, cut by this transversal? So what we're doing today is we're proving lines are parallel. So here are some ways that you can prove if lines are parallel using the following reasons. So corresponding angle converse. So we did cover a lot of that logic stuff with converse and inverse and negation and all that stuff. So if two lines are cut by a transversal so that a pair of corresponding angles are congruent, then the lines are parallel. So looking at this diagram here, if we have angle 1, right, this angle up here, equal to angle 5, or congruent to angle 5, I should say, then we know that L is parallel to M. So if 1 and 5 are exactly the same in measure, then that must mean they have to be parallel, because remember, these lines cannot turn or anything. They have to keep going straight. They have no way of doing anything like that. They have to keep going straight, and they have to be, if they're even like a small degree off, eventually they are going to intersect. L and M would. So there you go. And then most of these are just going to kind of be along the same line. So alternate interior angles converse. So the next one here, if two lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the lines are parallel. So here they have 4 and 6. So remember, alternate means the transversal. So it's like a switch. It's switched sides, so it's different sides. Alternate interior means that they are on the inside of the lines. In this case here, they are on the inside of L and M. And converse, so converse, again, well, in this case here, you could also have 3 and 5. 3 and 5 could also be the same thing as well. 3 and 5 would also be alternate interior angle converse. And again, with most of these, you just sort of have to like listen to them and kind of think, okay, well, what do each of the words means, and which ones, which pairs of angles could be those. So next one here, alternate exterior angles by converse. So if two lines are cut by a transversal so that a pair of alternate exterior angles are congruent, then the lines are parallel. So again, remember, alternate means separate sides of the transversal. Exterior means on the outside of those parallel lines. So in this case, it'd be like 1, 2, 8, and 7. But in this case here, we're specifically talking about 2 and 8. So you have that big angle up here, and if we switch sides on the other side of the outside of the parallel lines, that would be 8. 1 and 7 are also a set of exterior angles. Okay, alternate exterior angles. So both of those would work out. So that's how that would be another way that we could prove that L is parallel to M. All right, consecutive interior angles converse. If two lines are cut by a transversal so that a pair of consecutive angles are congruent, then the lines are parallel. So in this case, we're going to have to add a couple of things. So consecutive, remember, well, in this case, consecutive means that they are on the same side, right? So alternate means like it's switched, and consecutive means that it is the same side. So same side, interior angle, so on the inside, angle converse. So in this case here, they use the example of 3 and 6. So 3 and 6, those are, again, right, they're on the same side. So in this case, they're both on the right side. 3 and 6 are both on the right side of the transversal. And again, interior means that they're both on the inside of these parallel line pairs. So if we were to add those together, if we were to add 3 and 6 together, we would get 180. So that's the example they give us here. Well, you could also use angle 4 and angle 5. So if angle 4 and angle 5 were also, it would make that same pair. It would also work as a consecutive interior angles converse. All right, so next and last one, consecutive angles. I'm sorry, consecutive exterior angles converse. Okay, So if two lines are cut by a transversal so that a pair of consecutive exterior angles are congruent, then the lines are parallel. And then I pretty much know. So this would be consecutive again, means the same side. Exterior means outside. So 2 and 7 are both on the outside of the parallel lines. And they're also on the same side of the transversal. So 2 and 7 would be one example, but the example they went with is 1 and 8. So if you were to add angle 1 and angle 8's measures together, it would come out to be 180 degrees. So those are a couple of the ways that we could do this. So it's kind of, if you remember from yesterday, it's got those same 5 things to do. It's got the same 5, because remember yesterday we were talking about whether they were going to be supplementary, and that's what was going on here. And then over here it said congruent for these top 3. So in fact, you know, I could probably just zoom up there really quick and show you. And it's not really all that different. See, corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent. And then here we have those other ones, consecutive interior angles, consecutive exterior angles. So both of those are supplementary. And if we come down here, it's basically that same definition, right? Those bottom 2 come out to be 180. These ones here proves corresponding or congruency. Okay, so that's it for the basics. I'm gonna go ahead and move on down here. So let's see, determine if line L is parallel to line M based on the information given on the diagram. If it's yes, state the converse that proves the lines are parallel. All right, so here we have our lines here and our transversal. So in this case, we have a small angle up here where it says 63 degrees, over here also 63 degrees. So yeah, I would say they were parallel. Okay, now we have to say which rule are we saying makes them parallel. Okay, so alternate, because they're on opposite sides, right? This one here is on the right, this one's on the left. They're on the outside of the parallel lines, so that'd be alternate exterior angles converse. And again, there's only those options. There's not that many more options other than that. Okay, and then for the next one here, so number 2, we don't have a number, but we do have these angle arc marks, these little arches here. So with this, could we prove if it is parallel? Well, yeah. So that shows, okay, so that one that's going like this, that shows that it's the same angle as the one above it. And since they're the same, so corresponding angles, so corresponding angles would mean that it would be, corresponding angles are the same side, same direction from the intersection. So in this case, they're both upper right here. And if they're both the same, that means that they both have the same angle. And again, these lines don't curve or change direction at all. So in this case, yeah, corresponding angles converse. All right, let's go ahead and move over to this one here. So, well, we have 2 lines going up and down, and then we have that transversal going side to side. So if we look at the number here, we have 48 and 132. Well, they're not the same, so that must mean they're not parallel, right? Well, remember, there's other ones that we can go with as well. So in this case here, they're on the same side. So that same side means consecutive. Normally when we think of consecutive, we think of like one after the other, and that's what I would think of as well. But actually in this case here, consecutive means same side. And alternate is, again, switched, kind of like switching out a player as an alternate, right? If you have a player that does the same thing, or a competitor, like in the Olympics, and if one of them gets sick from eating bad sushi or something, then the other guy takes over. So one of the other converses we have is that if we add both of these together, so consecutive exterior, so again, they're both on the outside, so consecutive exterior, if it adds up to 180, then it's a yes. So now we know that this one would be yes. All right, let's move on to number 4. So I have 105 here, 105 there. So what does that mean? Does that mean yes? Well, no. In this case, both of those angles are talking about the same line, right? It's the same line. They're both talking about line M. They're not talking about L and M. Because you need both of them. Now, if it said maybe this one right here, like if this 105 moved over here, then we could say yes. Or if this 105 moved over here, you know, to the next corresponding angle, that would also be a yes. But we have no way of knowing if L has any of the same angles as our line M. So in this case, we can't prove it. I mean, it could be, all right? It could be, but it wants us to be sure. So in this case, no. All right, so here we have some of these lines, and they're coming in at a real big angle. So this angle and that angle are going to be the same. And in this case, yeah, it would be, because alternate interior angles. So alternate, meaning they're on the opposite sides of the transversal, and interior, meaning they're both on the inside of the parallel lines. So yeah, that's alternate interior angles converse. And let's go with this one here. So 65 and 125. Now, we could try to use the consecutive interior angles converse, and that would say that if we were to add these two angles that are on the same side of the transversal and interior of these two parallel lines, they should add up to 180. Now, if I grab a calculator and I add up 125 plus 65, I get 190 degrees. And we don't need 190 degrees, we need 180 degrees. So in that case, it's going to be a no. All right, I'm going to go ahead and move on down. It looks like we're going to have quite a bit of stuff to cover here. And that diagram on the left is what we're going to be using. So we just need to be proving a lot of these lines. So given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. Okay, so they have us a given, and we want to, like for instance here, we have 2 and 4. Okay, 2 and 4 are the same, and that means that the parallel lines that it does prove are C and D are parallel, because A is now the transversal. And since 2 and 4 are corresponding angles on each of their own lines, then that's why we put corresponding angles here. So that's how that's going to be done. And I'll give you a couple of, I'll give you a little bit of time here. Maybe I'll zoom out a little bit. I don't know if that helps out, because now you can see a little bit more. But now everything kind of looks a little bit smaller. So this way, faster writers can get a little bit further ahead, and slower writers, you know, we'll go through it a little bit more, but we will. I'll give you a minute or two to copy these down, so that way when you go over them, you know, you're not writing them down as I'm trying to discuss them. Okay, I am. Well, this morning I forgot to put water in the refrigerator. Usually I bring my own water in every day, but today I forgot to bring my own water in. And I don't like drinking warm water. I don't know, warm water just feels weird. So I took some of the water bottles that I had around and I put them in the fridge, and that would have been about 40 minutes ago. So I don't know if they'd be cold enough yet. I kind of woke up a little bit. Well, I wouldn't say I woke up late, I guess. I woke up on time. I guess I just took a little bit longer getting ready than I would have normally done in the morning. But either way, I didn't pack any water today, so I'm gonna go check on that water. All right, good. The water thingy worked out. Yeah, so it wasn't as cold when I got in here, so I ended up putting it in the freezer. And if you've ever put something in the freezer expecting it to be cold later, only one of two things will happen. You check on it too early and it's still warm, or you wait too long and it freezes and then it busts. So looks like it worked out just fine. I only left it in there for like 40 minutes or so. Not as cold as I would like it, but works okay. All right, so let's go ahead and go over some of these now. I'm going to zoom back in. I'm not sure how much time exactly that was, but moving down to the next one. So angle 5 is congruent to angle 10. That's our given. So 5 and 10. So 5 is here, 10 is here. So that means in this case, the transversal will be C, and A and B will be our parallel lines. So again, it's going to change every time. It's not going to be the same each time because since we have a lot of different things going on, well, it is going to change. It's going to change depending on what we're talking about. So which one does that prove? So it proves that A and B are the parallel lines. And 5 and 10, if we know those are congruent, that would mean that we used alternate interior angles. So again, alternate meaning opposite sides or switched sides. Interior meaning they're both on the inside of A and B lines. And let's see, next one here, we got part C. It's telling us that angle 1 and angle 13. Okay, so 1 is here, 13 is there. It says that they add up to 180 degrees. So again, 1 and 13, our transversal would be C, and the parallel lines we're talking about would be AB. So the AB is being proved that it's parallel. And consecutive means they're on the same side of the transversal Exterior means that here we have one on the outside and the other on the outside, so they're both on the outside. Since they're both on the outside of those parallel lines, that's why we call it consecutive exterior. So make sure we're still looking at part C. All right, let's look at part D of this answer, or I'm sorry, of this exercise. So angle 1 is congruent to angle 14. So 1 up here and 14 down here. So in this case, the transversal is C. And the transversal is the one that, you know, both angles lay on. But the parallel lines are, you know, those are the other ones that they lie on. So we have 1 on 1 and 1 on 14. So A is on 1 and 14 is on B. So that would mean A and B are being proven to be parallel. So we write AB here, and then our justification here would be, okay, so 1 and 14, they're on opposite sides, so that means alternate. And they're both on the outside of the parallel line, so that'd be alternate exterior angles. All right, and let's get ready to move to the next one. The next one's given is E, which is angle 14 and 15. So 14 and 15, put those together. So they're right here. If they add together, they become 180 degrees. So, okay, 14 and 15, they're both on B, right? They're both on B, so that makes that the transversal. 14 is on C, 15 is on D, so that would mean, well, C and D are the lines being proven to be parallel. Since they're next to each other and on the same side of B, right, there's B, they're on the same side of the transversal, that would make them consecutive and interior. So consecutive interior angles. All right, and now we have 11 and 16. So that's the next one. 11 and 16. Now this one's a little bit different because they're not laying on the same transversal, right? Because we don't know which one the transversal is. So both marks have to be on the transversal, and they each have to be on a separate line, which in this case, they're both on the same line, and we don't know which one the transversal is. Or we could say that the transversal is the same as well. So that's why there's none. We don't know enough to prove anything about this relationship. All right, let's move to the next one. Angle 4 and 15. So let's look at 4 and 15. So we have 4 here, 15 here. So again, they're both on the transversal D, but one is on A, the other's on B. So A and B are the lines being proven to be parallel. And it says here that 4 and 15 are equal, so they're congruent. So yeah, that is one of the ones. So they're on opposite sides. So that would make it alternate, and then they're both on the outside, which means alternate exterior angles. Okay, that one was a pretty easy one to go with. Let's go with 10 and 12. So 10 and 12. So they're both on B, and one is on C, the other's on D, so that's proving C and D are going to be the ones we're looking at. So that would be corresponding angles because they're both kind of in the same direction, right? Remember we looked up the definition for corresponding yesterday, and it means like they're comparable basically. So there's a lot of things that are kind of going, basically the way I described it is they are in the same direction. So 10 and 12 are both kind of on the upper right. So since they're both on the upper right of their lines, that's what makes them corresponding angles. All right, so let's go ahead and move on to I, which let's see, part I says that 9 and 13. So 9 is here and 13 are here. They're right next to each other, and actually they both share both the same set of lines. So in that case there's not really anything we can do to prove if they are equal or different or anything. We don't know anything about any of the relations with these lines. And we're not going to use any other information here. So I know we did a lot of other parts to this exercise in talking about it, but every time you do one of these, you can't just assume, well, the last time they were parallel, so they will be parallel now. No, it's got to be each one, new exercise on each one. All right, so let's go ahead and go over here. So 2 and 7. So 2 here, 7 there. Okay, so they both lie along A. One lies along C, the other lies along line D. So that is proving that C and D are parallel. And they're on opposite sides. And they're on the inside of the parallels. So that makes them alternate interior angles. All right, 6 and 11. Last one here, way down here, K. 6 and 11. Well, there's no line that either of them both fit on. So there's kind of no transversal in this case. So 6 and 11, they have no lines in common. 11 lies on B and D, and then 6 lies on A and C. So there's nothing we can really tell out of that. So that's why there's none. And again, we can't use any of the other justifications to say this, because a lot of times, all of these exercises use the same diagram, but that doesn't mean the diagram is necessarily correct either. Or as I said at the beginning of the year, don't trust the diagrams. All right, I'm going to go down here, and hopefully everybody got that top part. We're going to cover this part here, and then I think the next page, and I think we're going to be finished with this this first part here. So I'm going to leave this one open. I know some of you might have gotten to this part here, but this part down here we haven't got to. Or if you needed more time to write, maybe you're still getting this part here. So I'll go ahead and give you a minute or two to write those down. Okay. Yeah. Oh. Okay, just have to take care of a few things, and now I'm back here now. So let's look at what we have here. So 9 and 22. So angle 9 and 22. Ooh, I'm gonna have to zoom in a little bit on this one here, because otherwise our diagram would be a little bit too small. So 9 is here, and 22 is here. So, excuse me, looking at just 9 and 22, S would be the transversal. And since one line or one angle lies on Q, the other on R, that means we're proving Q and R parallel to each other. So 9 and 22, if we look at how they relate to their lines that they're talking about, 9 and 22 are on the outside, so that makes them exterior, and alternate, meaning they're on different sides of their transversal, so alternate exterior angles. All right, so that takes care of that one. Let's go ahead and look at B. So this would be 8 and 13. So 8 and 13 are right here next to each other. And it's telling us that if we add them together, their angle should come out to about 180 degrees. And 8 and 13 both lie on T, and then they each have P and Q. So P and Q are the ones that they are showing are parallel. They're on the same side, so they're both on the left of the transversal, and they're right next to each other on the inside. So that means they are consecutive interior angles. All right, now let's see, 1 and 17. So 1 and 17 are over here. So in this case here, they're both on S. So S is the transversal. P and R are the lines that they're on. So 1 and 17, yeah, it is P and R. So P and R are the lines that are being proven to be parallel. 1 and 17 are both on the upper left. So they're both on the upper left side. So that would make them corresponding angles. And if we know corresponding angles are the same, that means again that the lines have the same angle, the same direction that they're going. So that must mean that they have to be parallel. All right, let's go with D. So part D says 16 and 20. So 16 is here, and then I'm going to look a little bit for 20 over here. So 16 and 20 right there and there. So T is the transversal, and one is on Q, the other is on R. So they are proving that Q and R are parallel. Alternate interior angles. So let's see. Alternate interior angles. Oh yeah, sorry. They're both on the inside of Q and R, and they're on opposite sides or switched sides of T. Now be careful, because again, some of these may have none, okay? They have no relation. So 10 and 13, here and here. 10 and 13, well, they don't have anything going on because they're both on P, and ST are obviously not parallel. So knowing 10 and 13 are congruent doesn't prove anything. Okay, it doesn't prove anything. It uses none of those things that we covered. So that's why it's none, and we don't have to put anything here because it's not proving that it's parallel. All right, so let's go ahead and move on to part G. So angle 3 and angle 22 are the same. So angle 3 here, and then angle 22 here. So it says they are congruent. So that means that they are proving P and R. Something's up with P and R, so we know they're parallel. They're also corresponding angles. They're also both lower right of their intersections. So that one's probably one of the easier ones to kind of know is that one, the corresponding angles. 5 and 15, so 5 here, 15, where's that at? Right over here, 5 and 15. So they're proving P and Q, so P and Q are the parallel ones, what we're talking about, and T is the transversal. They're on opposite sides, so 5 and 15. So one is on the upper right, upper left, and this one's on the lower right. and they're on opposite sides, and they're on the outside of P and Q. So that makes them alternate exterior angles. So that's that one. And then last one here, last one, 2 and 16. So angle 2 up here and 16 over here. Well, again, they don't share any of the same lines at all. And that's one of the things that they have to do. They have to share at least one line. The line that they share would be the transversal, and the ones they have unique to them would be the lines you're proving parallel. In this case here, that's going to be none of them. They don't have anything in common at all. So we can't really prove any relation with anything here. Okay, so I think I gave you enough time to write these ones down. So I'm going to just go ahead and go right into it. Transitive property. So remember that transitive property is, it's that story that I kind of mentioned, like if you're playing basketball and your friend says, hey, my cousin's going to come by to play basketball. And you know that you and your friend are the same height, and you ask your friend, well, how tall is your cousin? And he says, well, he's about my height. So that means that all three of you are about the same height. So that was the transitive property, that A equals B and B equals C. So A must equal C. All right, so let's see how it works in this case here. So if A is parallel to C, so here we have A and C are parallel, state which other lines would be parallel and why. So A and C here and here. Well, looking at the top of, well, all right, so we know they're parallel, that's a given. So B and C are consecutive angles. So here, consecutive exterior angles are supplementary. So B and C, looking at B and C, they're both on the outside, so 84 and 96. Those would add up to 180. So if we know that A and C are parallel, and we know that C is parallel to B, then A is also parallel to B. So by the transitive property, both of those parallel lines, AC, so A, and that's our given. Remember, we always assume that the given is true. A and C are the same, and we know that proving B and C are the same, right? Because exterior angles are all consecutive exterior angles. Therefore, that's what those 3 dots mean. 3 dots are, therefore, A is parallel to B. Ooh, okay. Yeah, I know that one is kind of a little bit different and a little bit more. So I think we're going to keep going. I think we can do one more page and then we'll be done. We started a little late, so I'll go ahead and zoom out a little bit. And again, we're just going to cover this page, and that will be it for the lesson today. Whew. All right, I just looked at the time and I realized that we don't have a whole lot of time. I'm gonna try to get as far as I can into explaining some of these, and whatever I can explain, I'll go ahead and just let you see it and show you. So find x so that a and b will be parallel. State the converse used. Okay, so let's see, we have 10x minus 23 and 137. So what kind of angles are these? Well, they're alternate interior. They're both on the inside and they're both on separate sides of the transversal. So we know that in that case, well, we'd have to use that chart we used earlier. We know in that case that they would be congruent. So that if they're congruent, we can set them equal to each other. So 10x minus 23 equals 137. 10x equals 160. So we, in this case here, we use the addition statement, we added both sides. We added 23 to both sides. 23 plus 37 would be 160. And what number times 10 can give us 160? Well, that would be 16. And there we go, we got it. We got the x that we need. All right, let's move on to number 2. So here I have a and b, and they're both the upper right side. That means they're corresponding angles. So corresponding angles means that they would have to be congruent or equal to each other. So we're going to go ahead and drop them into here. 74 equals 9x plus 11. And we're going to have to subtract 11 from both sides. So 74 minus 11 would be 63. And that leaves us with 9x equals 63. So what could I put in there for x to make it come out so that when we multiply it, it goes to 63? Well, that'd be 7. So x is equal to 7. Okay, so I'm going to try to go over these two here, and then we'll do our student independent learning. All right, so what's going on with these two? Okay, so they're not on opposite sides, so that means they are consecutive. They're both on the inside of their parallel lines, so that would mean interior, so they're consecutive interior. And remember, those ones are different because they're not equal to each other. But if you add them together, they will come out to 180. So that's what we're going to do. We're going to put 96 here, and then 6x minus 30 here, so that they come out to 180. Now, just use your normal algebra stuff. And I know sometimes, you know, it's great to see the steps and you can see like the adding and subtracting to both sides and that kind of stuff. But in this case here, okay, so what happened here? Well, it looks like they had 96 minus 30, and that's where they got 66 from. So they simplified both steps. So remember, that was one of the other things that we did when we were talking about algebra stuff, is what happened there. And we don't have to, you know, in this case, we don't have to do anything. We can just use our algebra steps as normal. But yeah, that's what happened. We simplified, or as I like to call it, combined like terms. Now we have x on this side, so that means the 66 has to go. So since we're adding 66, to get rid of it, we'd have to minus 66. So 180 minus 66 would be 114. So that's where they got 114 from. Now 6 times what will give me 14? And that one's a bit of a tough one because I don't think most of our multiplication charts go that high. So we'd probably have to use a calculator for that one, or divide both sides by 6. And that would give us 19. Okay, so let's move on to number 4. And in this case here, let's see, I have the transversal here and these little tiny angles here. So looking at what kind of relation they have, they are alternate because one's on the, well, if you look, that 33 is kind of on the right, and then the other one is on the left. So that would mean that they are alternate. And then they're on the outside, so that's exterior. So remember, alternate exterior angles would be congruent or equal. So we're going to set them equal to each other. 33 equals 7x plus 5. And then we start doing our algebra stuff, which again, I'm not going to spend too much time on it because, well, algebra is something you should be like kind of a master at right now because you've been doing it for a few years. So minus 5 from both sides. So 33 minus 5 is 28. As much as I'd like to go over each of these, just the time is just not going to allow it. All right, I want to get through this packet by the end of the week. 7x equals 28. So what can I multiply by 7 to get 28? Well, the answer is going to be 4. So there you go. And it's pretty easy. All you have to do is know the relation between the angles, right? Some of them, I don't know if any of them would be none. But what you would do is once you know that relation of the angle, they have only one of two possibilities. They can either be equal to each other or they can be added together to make 180. So what kind of relation did they have? All right, that's the thing that you gotta cover yourself. And that's one of the things you hold on to the reference page for, okay? So anything that has a lot of information like that, try to make a set of notes so that way you can work on it in the future. In the meanwhile, I'm gonna go ahead and get this ready to go. We're gonna stop the lesson and go into the independent student learning for now. So you're welcome to stay, and don't forget, I encourage you to ask questions. So if you need any help with any of the work, all right, that's what I'm here for. That's like most of the reason I'm here for. And that's why our breaks, the independent student learning, in this case, it lasts nearly an hour. Okay, so that hour is there for you to catch up on these things, to catch up on your work. If you're having trouble, don't be afraid to ask, because there's always the chance that somebody else has that same question, right? And if we don't ask any questions, you know, you know, whose fault is that? I don't want to blame you and all, but, you know, don't be afraid to ask, because I don't want people being, at the end of the course, I don't want people saying, well, you never helped me. Well, this is what we're doing now, and it's up to you to ask for it. All right, so I'm going to go ahead and sign off, and I will meet you back here at 9:45.